Power tells us how quickly something can do work. In physics, when we say do work, we mean change energy. So power is the rate of change of energy. So how does this apply in electric circuits? Well, let's take a look. Power is the change in energy or work done divided by time. The more powerful something is, the quicker it can change energy. A jet engine, for example, can turn the chemical energy in its fuel into kinetic energy much more quickly than a Honda Jazz can turn the chemical energy in its fuel into kinetic energy. The jet engine is more powerful. The symbol for power is P. But what is the unit of power? Okay, I'll save you the physics teacher jokes. The unit for power is the watt. It's named after James Watt, the Scottish engineer who developed the steam engine. He didn't invent it, but he developed it quite a bit. As we've already mentioned, power is changing energy over time. So if we take a lamp that's in a circuit with a power of 12 watts, that means it can take 12 joules of electrical energy and convert it to other forms of energy every second. Hopefully, most of that energy will be light energy. If we want to measure the power of a component in a circuit, then we need a voltmeter and an ammeter. Let's stick with the idea of using a lamp. The ammeter gives us the current flowing through the lamp, and the voltmeter gives us the potential difference or voltage across it. If we multiply the potential difference in the current, then we get the power. So power is I times V. Why is that? Well, if we look at the equations for current and voltage, here they are, we can see that if we multiply them together, then we get I times V is Q over T times E over Q. And the Q's cancel, and we're left with energy over time, which is power. Don't worry, you don't need to remember that little bit. I just thought you'd find it interesting, and it might annoy you if I just told you P equals IV without telling you why. Let's look at an example. A 24-volt electric motor is supplied with a current of 6 amps. What's its power? Well, power is IV, the current is 6, the voltage is 24, so 6 times 24 gives us 144 watts. Here's another example. What current is needed to run a 690-watt microwave oven at 230 volts? P equals IV. You can either use the triangle or your math skills to rearrange it to get the equation I equals P over V. Our P is 690, our V is 230. 690 divided by 230 gives us 3 amps. Sometimes we also need to consider resistance. If you don't know much about resistance, then I've made a video all about that, and I'll leave a link in the description. You could also subscribe so you could easily find my other videos. As a bonus, I do worksheets and answers to go with every video I make, and they're available on my website. You'll also find links to one-to-one lessons with me, as well as revision courses. Everything's in the description, but check out the website. From Ohm's law, we get V equals I times R. If we substitute that into the power equation for V, we get P equals I times I R, which is I²R. These equations are all on your GCSE formula sheet. Let's take a look at one last example. A 20-watt lamp has a current of 2 amps flowing through it when it's working at the correct voltage. What's the resistance of the lamp? P is I²R. The power is 20, the current is 2, so we get 20 equals 2 squared R. Let's simplify that, so we get 20 equals 4R. Let's isolate the R, so we get 20 over 4 is R, and 20 over 4 is 5. So the answer is 5 ohms. Now, watch this.